The next session we will be discussing is about expressions in Go. Expressions in Go. We are going to discuss about expressions in Go. Okay. Some programming languages, they use some syntax. See, even a block is also can be created as an expression. Okay. uh, Even the of course the relation operation, relational operators also, or a comparison operators also can be created as an expression, but what they give is they give true or false. Basically they give true or false. You also have got logical expressions like and, or, not. You can also perform logical expressions on variables. uh, what they give logical expressions. Basically they give logical expressions like, maybe you put true and false, it gives false, false, true and true or false, it gives true, not true, it gives false, something like you and or not and all these are all logical expressions, but you need to understand, uh, expressions are the fundamental building block of evaluating values or performing some kind of computations. Ultimately, what you do in a program, whichever the programming language you use, basically, what does a program contains? A program contains if else, a program contains loops, conditional executions, variables, and then operations. Could be arithmetic operations or logical operations or kind of uh, bitwise expressions or bitwise operations or also assignment expressions. There are some in Go, but however assignment expressions are also in Go. We will see that. Okay, so let's start with a very simple expression. Okay, let's say mkdir 7. I just would like to keep this concept of expressions for understanding arithmetic expressions, logical expressions, and also uh, comparison expressions like relational expressions like greater than, equal to, and stuff like that. Okay, so go mod init demo init demo. This has created a Go mod file. It's very important right now. It may not be that important, but going forward, once we start creating packages, our own packages and all, this is very, very important. Using third-party packages or using our own packages, this is very, very important. The Go mod file. Right now, we are simply creating a Go module for the sake of the project structure, but it has got a paramount importance. Code main.go. Here you go. Package main, function main. Couple of things we will discuss here. Let's say I create a variable called A100 and then B equal to 200 and also C equal to maybe 10. That means we have created three variables. These are all shorthand notation. You know that what shorthand notation is. Based on the value, the type is inferred. Sometimes based on the type, the value is inferred, which is a default value. But here, based on the value, the type is inferred. A is integer, B is integer, and C is also integer. For a simplicity, you can give 0 so that you can also cover writing expressions and performing some arithmetic operations on them. Okay, I want to perform a very simple expression. Okay, let's say a simple expression a plus b whole square. A simple expression called a plus b whole square. S square plus b square plus I'm giving 2ab. I don't know, here I cannot put that square on top, so as a superset, a square plus b square, let it be, plus 2ab. So this is a plus b whole square. How can you write an expression for this? That means the left hand side, okay, I'll give as d, let it be simple. A square, that means a into a, plus b square, which is called b into b, plus 2 into a into b. This is what actually, this is an expression basically. You are performing an arithmetic expression. A square plus b square plus 2ab, that's what you are doing. Okay. So you know the precedence table comes into the picture. You know about the how the expression is evaluated. Basically, any expressions are evaluated not only in Go, any in any programming language. It's based on the precedence. Okay, priority or precedence. Brackets gets the highest priority. You can go and check the precedence table of Go. Okay, go and have a look at it. Brackets gets the highest precedence. Brackets will get the highest precedence. After that, multiplication operator, division, and then modulus operator. That means it goes, the precedence goes like this. Precedence, this has the highest precedence. After that, there is a multiplication operator, there is a divide operator, there is a modulus operator, and then bitwise shifts, left shift and then right shift, bitwise shift, and then and bitwise and operator, and uh, bitwise and then what's where is it, not operator gets the highest precedence. It's all based on the what kind of formula they use. And then the third comes as plus and then minus. Go has something called this kind of operator. Sorry, this operator is very famous in Go because of tags we use. And then the precedence goes to uh, relational operators, less than, and then less than or equal to, and then greater than, and then greater than or equal to. These are the operators, and the precedence goes to this. uh, I'm not writing everything. I'm writing there could be this and then this. Here also it goes this, the pipe symbol, bitwise or operator, like that the precedence goes. So uh, the precedence, operator precedence is very important. Generally, brackets gets the highest precedence, that we know. That even square brackets are there, curly braces are there, they also have some precedence. I'm not writing the whole precedence map, but just giving you some overview of what precedence is. That means in an expression, if an expression has to be evaluated, highest precedence goes to the bracket. It goes inside the bracket. That means in if there is a big expression, let's say there is a big expression, let's say I write like this. Which part of the calculation is evaluated at first? Which has got the highest precedence? The highest precedence is at this. So this particular calculation happens first. After that, what has got the highest precedence? Highest precedence has got this. Maybe A is 2 and B is 3. So 2 into 2 is 4, and then 3 3 into 3 is 9. These two has got the highest precedence. 4 is stored in some temporary variable or somewhere internally in registers. 9 is stored in some registers. And then the highest precedence goes to into operator, not to plus. Remember that this would not be calculated. If plus has got the highest precedence, then immediately it goes the plus operator, but not the plus operator. The highest precedence has got the multiplication operator. Then 2 into, that means 2 into 2 into 3, 4, and then 4 threes are 12, right? Then 12 plus 4 plus 9, whatever, 12 plus 9 is 21 plus 4 is 25. That is how it gets the precedence. So precedence table is very important. Generally we don't care much about it, but for some calculations I had some issue actually long back. I was working on a project which is called a on the metallurgy. It's on a petroleum based project. A petroleum based project is on a rig and all. Then heavy calculations are there. Heavy calculations there. Actually, my calculation was going wrong because of what my understanding on precedence. I was not really care about the precedence. I was just doing some calculation in my own way. I was doing calculation like a mathematics, but it is not true. Basically you should know the precedence. At least if you don't, we cannot by heart precedence and all, because I know only few things, so I put it over here. This is, don't think that these are 100% right, because of some idea I know. Brackets has the highest precedence, and into and bar by has the second category precedence. I put like this. Maybe little differences are there, but ultimately I know that these two has the highest precedence. After this only plus and minus comes. But I know bracket has got the highest precedence. So the precedence is very important whenever you are performing an arithmetic operation, and not only arithmetic, any expression you are evaluating an expression, because expressions are evaluated towards the right side, the values are given to the left side. Whenever you are evaluating an expression, it's very important to understand the precedence of the operators. Okay, precedence tells that what part of the expression is first evaluated is what actually the precedence is. Where it has to start, from where it has to start. This is a whole expression, it has to be evaluated from where. It doesn't evaluate from starting to the end. It is evaluated based on which operator has got the highest precedence. That's how any evaluation happens. We get actually a print line of square a plus b whole square is d. A simple operation. C was declared but not used. Sorry, go run. Okay, I because this is not 2 and 3, this is 100 and 200. However, so the right side is an expression and the left side is something. Okay, cool. A simple thing. Okay, this is nothing but this is not related to, okay, it can be treated as an expression as well. Let's say that I would like to swap the values from A to B. How do you swap values from A to B? Generally what we do, we create a variable called temporary variable. Temporary variable get the value of A, and then A equal to B, and then B equal to T. This is what we do. This is how the values are swapped. You create a temporary variable called T, in which you create a variable A, you put it in the temporary variable, so the value of A is already there. Then we overwrite A with B, and then you keep the value of B to from T, which was storing the temporary value of A. This is what you do swapping. Swapping is a very regular operation in a very regular operation. We do swapping very regularly. But in Go, you don't need to do all these things. You can simply swap. You can simply swap. You can simply swap A comma B equal to B comma A. This is a very, very simple swapping. In fact, this is not limited only to two variables. You can also do with three variables. Let's say there is a variable called C. For now, I'm keeping it as integer 300. Then I would like to swap ABC. I'm just swapping A comma B comma C equal to, maybe I would like to give as what do you give? I give uh, C comma A comma B. That means the value of C is in A, value of A is in B, and then value of B in C. This kind of swapping, this is a swapping of, even you can swap four variables. So Go is very, very intelligent of all these things. You don't need to really worry about how do I swap these variables. Swapping can be done in Go just like this. You don't need to create a temporary variable and then keep the value for some time and then do that. You can directly do all these kind of swapping kind of things in Go uh, directly. Right. If you want, you can just print line ABC. You get to know that the values, how they are printed. A has got the value of C, which is called 300. B has got the value of A, which is called 100, and then C has got the value of B, which is called 300. The swapping can be done very, very easily. Even you see a lot of people, usually I also used to do like this, because this is how we used to do swapping. But you get a lot of review points, review remarks. Whenever I did initial days of my Go, I used to swap like this. I was not aware of that you can do swapping like this, because we learn things by doing but not reading the specifications or documentation. So I used to do swapping like that, but later on I realized that this is not, you can, there is a easy way of swapping variables in Go. You can do that. Okay, coming to the uh, arithmetic operators. Okay, come back. So you know that how do you do expressions and then arithmetic operations. The This is an expression. Expressions are nothing but the value is evaluated and returned. You can also do expressions. You can also do a lengthy expressions through anonymous functions. We will discuss about some programming languages. You can also do expressions like this, where okay, E equal to, you can put a something like this, maybe A into uh, A into A. For example, A square. E is nothing but A square. But Go doesn't accept this kind of. A scope is also considered as an expression in some programming languages. Rust does this. You can do it in Rust. Instead of where you put a let and then it is a valid statement. Of course, you cannot put like this. You can put a let. This is a valid expression in Rust, because if you don't put colon, it is considered as a return. Okay, let me put where, let me put this, and then I put it as a return. Unfortunately, or fortunately, whatever the thing is, it doesn't want to complicate too much. This is not valid, but this thing can be done using anonymous functions that I would like to tell later on. If you write a function which can return this value, which can be evaluated, but these are all anonymous functions. Okay, we will discuss about it in some time later, but right now you can't do this. This is not doable unless you do anonymous functions. Right. Okay, let's say that let, sorry, so where k1 equal to A equal to B. What does it mean? A equal to B is an expression. A equal to B is an expression because this is a comparison operator, relational operator. What you are telling is the whole thing returns true or false. So like arithmetic operators, these operators these operators can also be used for expressions. A equal to B, this particular expression, if you look at it, it gives true or false. Okay, it gives true or false. So k1 is a boolean variable. Now k1 is a boolean variable. You see that k1 is bool. Of course, if you want, you don't need to do this. You can do this. K1 is boolean. K2, just want to give A is greater than or equal to B. K3 is nothing but A is less than or equal to B. These are all expressions. These are all expressions. In just a print line, you can put K1, K2, K3. Any one among them would be true, basically. The middle one is true. That means K2, which is A is greater than or equal to B. Because how does A become greater than B? Because A is 100 and B is 200. The reason is we have swapped here. Because we swapped here, I think the value of A is 300. That's the reason. The value of B is 100. That is the reason actually A is greater than B, because this has come as true. In fact, this is not only stopped here. You can also have a complicated operations as long as these are all logical operation. I'm not going to bitwise operations. If you want, let me know. We will have a separate session on bitwise operations. We may have to do little in depth about bitwise operations and then look into that. Let's focus on arithmetic and relational operators right now. Let's say that A plus B, and I'm doing something. I'm doing something which is maybe meaningless, and K2 or A is less than or equal to C. If you really look at it, if you really look at it, the problem is, okay, here I have to do just with A plus B I cannot perform, because A plus B is going to give a value. A plus B is going to evaluate a value, and then you are checking the value with K2. What I can do is A plus B is less than or equal to 500. So this becomes, so the whole expression, either it gives true or false. I tell you why, or I tell you how. A plus B, here A is 300 and then B is 100. So 400 less than or equal to 500, which is true. So true, and K2, we know that K2 is already true. Or A less than or equal to C, which is false. So this is the whole expression. true into true or false. That means true into true is true or false, true or false equal to true. I think K4 should give true. K4, how K4 has evaluated a true? The whole expression is evaluated. The whole expression is evaluated. That means again the same thing, which has got the highest precedence among all operators. Bracket. This is evaluated. After that, less than or equal to. After evaluation, it goes to less than or equal to 500. This one is calculated as one expression. And operator it goes, and K2 is true, and the last one is false. So everything is this. The whole thing is called as an expression. So logical comparison operators, we are using arithmetic operator, we are using comparison operator, we are also using logical operator here, and or logical operators. Okay, you can put it in if condition. Actually, the actually if you put if K4, instead of this expression, the whole, for example, you want to create a if condition with this much of expression, you can evaluate everything even before if, put it in a variable, and then you can also put in here. That is possible. Just giving you some example. And this is what actually expressions in Go. If you really would like to know how the expressions are, what are called as, what all called as expressions in Go, these are all called as expressions. So to summarize, uh, expressions in Go, you should know what expression is. Expression is something that is evaluated and the value is returned. Something that is evaluated and the value is called returned is called as an expression. You can perform expressions. Expressions are generally on arithmetic operators, logical operators, and then comparison operators. On these actually you can perform expressions, not only in Go, in any programming language. How the expressions are performed based on the precedence of the operators. This is a typical example. We have created these operators. We have a plus b. One is an arithmetic operator, one is a comparison operator, less than or equal to, and other one is a logical and operator and logical or operator. You see we have created something just mixed and matched. What, if you ask me what is the meaning of this expression, I can't tell what is the meaning, but what I mean to say is I just would like to explain how things work. So what is an expression? What is a statement? Statements are executed, but expressions are evaluated and the value is returned. So should I keep the value, whatever the value is returned? Okay, can I keep the value or not? If it is an expression, you must keep the value. You cannot leave the expression like this. You cannot leave the expression like this in Go. Some programming languages, it is okay. You can create an expression, but you have not catch the expression in any statement. But in Go, if there is an expression, you are evaluating an expression, you must catch the value of an expression. Otherwise, there is no meaning of even writing an expression. Why do you put unnecessary burden on your CPU to perform some evaluating some expression when you don't even take the expression? So the compiler doesn't accept, because expressions, you are performing an expression means there should be some reason. You buy a ticket, then you should go to the movie. Right, if you buy a movie ticket, you go to the movie. But in movie, even if you don't go also, there is no problem. That is a different thing. That is a different thing. There are certain things that you must do it. Okay, you have a family and you are the main person of the family, then it is your responsibility to feed the family. You cannot sit simple at home and all. So if there is a responsibility that the compiler is taking, that to that your processor is taking to evaluate something, you should hold the value. You should hold the value. Okay, but you can do this. You can take all the expression and then you can print it. That is fine. The reason is still you are taking the value, you are evaluating and then passing into print line statement as a parameter, because print line is a function. You are passing it into you are passing the complete evaluation into a function, then it will print as true or false. That is fine, but you cannot leave the expression unused. Okay, you cannot leave the expression unused. That's very important thing. If you have any questions, let me know. Otherwise, uh, I'll move to a simple uh, something like if else conditions and all. Okay, I hope you got it. This particular concept, expressions in Go. The next concept is 8 if else. Go mod init demo. Go sorry. Code main.go. Here package main, function main. One thing in Go, that whenever you are performing any kind of evaluation, you can perform evaluation on same types. Arithmetic operations you can perform on same type. You cannot go and perform arithmetic operations on different types. Let's say one is called, let's say simple thing. Uh, so where num1 is uint 8 equal to 100, where num2 is int equal to 200, you cannot say sum equal to num1 plus num2, or you cannot say OK equal to num1 less than or equal to num2. Okay, the types must be same in order to perform these arithmetic whenever you are trying to use arithmetic operator or a logical operator. Okay, the times the types must be same. You cannot perform these operations on different types. Either you have to cast them or typecast them or type assert them, whatever you do. If it is any type, then you can perform type assert. If it is a arithmetic operation on normal type, you can perform typecasting, but without doing that you cannot do that. Either convert uint as int, and perform the operation. Without doing that you cannot perform the operation, these operations. So it's not only just expressions, there is a type system involved. In that you have to be very careful while performing. You may get errors like this. That means you are trying to perform some operation, uh, either arithmetic or logical or conditional operation you are performing, or a combination of all this on a mismatched types, which is not allowed in Go. Python and all, I think they allow. Python, JavaScript and all they allow, but compiled programming languages they don't. Even C Sharp and Java they allow on some types. If they are numbers like long and then int and all, certain things are allowed because there is an implicit conversion happens, implicit casting or implicit conversion happens before it's going to be executed. So at compile time itself, so it is accepted. But in Go it is not accepted. You have to be very careful about performing these operations. Okay, I'm just for explanation I gave this. A simple, a very simple, you have a number and then you have a number, num1 as some number. So what is this? If you really think about what is this, num1 is a variable that is evaluated at the compiler. What is evaluated? The type is evaluated by the compiler at compile time itself, because we are using a shorthand syntax. The compiler understands this value, it understands that it's an integer value, and then internally it creates it as where num1 as int. This is created internally. Though you are not doing it, it is doing it internally at the time of compilation, not at the time of running the application. At the time of compilation, before going to run the application, because it's a compiled language, some compiler optimizations happens. So this is one of them. Actually, compiler generates code for you before going to even do the next step, even before going to parse or tokenization or all these things. Compiler first go and check these things and then convert these things. So if you really create a variable properly, that means you are trying to bring down the burden of a compiler, because Go is designed for fast compilation. So what I do usually is I always create variables like this. Okay, I just want to say that the number is even number or not. So in order to check whether a number is an even number or not, what have to do this? How do you do this? A simple if else condition. So you use modulus operators. If the modulus the remainder is 1, the remainder is 1, it's an odd number. When you divide it by 2, if the remainder is 1, it's an odd number, and the remainder is 0, then it's an even number. So what I do is, if perform some arithmetic operation here, num1 modulus 2 equal to 0. You see that there is an arithmetic operation and then there is a comparison operation. So first of all, what is evaluated? This is evaluated because there is a bracket. Num1 modulus 2, that means by 2. By 2, whatever it is, since the last number is 2, it is an even number. So the remainder comes as 0, then it is an even number. Print num1 is even number, else print line num1 is odd number. That is very simple expression. It's a simple thing with the if else condition. A simple if condition equal to 0, it's an even number, and then it's false, it's a odd number. Okay, then go run. So is an even number. If you go and change this to thinking that to odd number, then it says that it's an odd number. So most important thing what you have to understand is, if you do like this, if you do like this, still it is evaluated properly. The reason is why still it is evaluated properly is modulus has the more precedence than that logical comparison operator equal to. So still num1 by 2 is modulus 2 is evaluated. So arithmetic operators are generally having high precedence than the uh, any other operators. So brackets are given the highest. So but since we used to do like this, we do that. And in one more thing is, in Golang you don't need to give brackets for each and every if statement. You can do like this. Let's say it's a very simple statement. You don't need to even a simple statement. Let's say if okay. Let's say if true. But you don't need to give a bracket here. If you have arithmetic and then combination of operators you are using, you may have to give some brackets, or you may give whole bracket. That's fine. Even you don't need to give a bracket over here. If you give it also no problem, but you don't need to give basically. You see when I saved it, it's gone. You don't need to give a bracket in Go. And one more thing is, this curly braces must be started here. Must be started here. You cannot create curly braces over here. It's an error according to Go. Even function also. You cannot even function also. You have to create here end of the function, end of the scope. The scope has to be started here. You cannot go and give here. It's considered it as an error. very very careful. Sometimes you go and then hit enter thinking that C language and stuff like that, or C sharp, and then you try to compile, you get an error. The reason is the scope operator should be end of the scope, should start from the end of the scope. There is a reason for that, because if you don't give there, the problem is compiler always keep a colon over there. Okay, how does it know it should put a colon or not? It doesn't want to do lot of logic over there. So this is a must rule, because here it puts a colon, here it puts a colon, but here it doesn't put a colon because it knows that you are writing something like if else or for loop or something. So there it doesn't need to put a colon. That's how actually Go does things. Okay, that's how Go does things. So don't worry about it. Just put a uh, just starts the scope operator over here. This is a very simple if else condition. Going to that if else, and then maybe even bigger one. Let's say that I create a gender. I create something like this where age, our age is event age, and then where gender is room. I don't need to give room. In fact, I can give even, you know, that in 32 as well. Okay. Let's say that whether somebody is allowed to marry or not according to Indian law. So what is the rule? If age is greater than 18 and gender is female, then eligible for marriage. Similarly, if age is greater than 21, I think equal to also greater than equal, and gender is male, then eligible for marriage. If not, if anything is wrong, not eligible to marry. Right. A simple thing. So age, I give age and then I give gender. Scanning the value, giving the value from the keyboard and all, I will explain later on. Fine. I give age as 18 and they give gender as F. Okay. What I do is if age is greater than or equal to 18 and gender equal to female, she is eligible to marry because her age is and her age is this. Fine. Then I would like to cannot go and write else condition because there is another condition that has to be so else if age is greater than or equal to 21 and gender equal to male, assume that M is male, sorry, and you don't need to give brackets, that's what. Then print line, he is He is eligible to marry because his age is whatever the age that got to be. And then else. If you want to write else also with the gender, it's fine. Then print line, he or she is not eligible to marry. That's all. If you want to complicate it, you can write more statements. You want to particularly print if she, if he, and all. So this is how you write if condition, you write else, and then if condition. Like that, you can write any number of else if conditions. I'm not explaining so much about if else. I think many of us are already aware of that. Go run. So she's eligible to marry. Let it be. Then 21, and then male. Go run. He is eligible to marry. Then 16. He or she is not eligible to marry. We can do. What if I give F as a capital letter? What if I give F, can Fn can also be a capital letter? Then what I do is I put this, or gender equal to female F, or that means any one is fine. Similarly here also I put or gender equal to capital M. I put or operator because this is one expression, and this is evaluated and get true or false. Based on that, it happens. M 21, 20, 39, for example. Go run. He is eligible to marry because his age is 39 years. Something like that. Okay, here I would like to particularly print he or she. So for example, age is not matching. Age is not matching. For example, then I can write again if gender is this, else if gender is this, and then else, that means you have not given either F or M. Okay, print line, uh, unknown gender. If you want to give any other gender and write the condition, transgender or something, you can give. But here I'm okay to write only F and M. Unknown gender because I don't know, but transgender, what is the age that is eligible in India? But this is how unknown gender, unknown
Jitin, I
gender.
have one question. So why you are writing in this code again in the else block? Because already we have written for in if and
Because
then if.
if and else is talking only about both the conditions are true. Both this works only when both the conditions are true. Both the conditions are satisfied. Let's say that, and none of the conditions, these two, none of them are satisfied, but you cannot write whether she is not eligible to marry or he is not eligible to marry. You can write not eligible to marry. Basically, what you can write, not eligible to marry, but specifically you want to write two different statements. She is not eligible to marry or he is not eligible to marry. Then you have to write like this again in the else condition. That means, however, not eligible to marry, whatever the reason, whether it is due to age or something, however not eligible to marry. But you want to be very specific that write a condition for she and write a condition for he, then you have to write like this. See, that's what actually I did. Let's say I give like 20 years and the gender is male, then go run. It it clearly tells that he is not eligible to marry. So I want to not eligible to marry is a common statement, but I want to be more specific that whether she or he, let's say I put it as female and then I give it as an age like this, let it be 17, then go run. I want to be very, very specific that she is not eligible to marry. So he or she, you want to be, else is fine. But you want to be very, very specific about he or she, then definitely you have to write a condition somewhere in the else part. Otherwise, you can write he or she is not eligible to marry in a single statement. Because
Got it.
how, yeah, how it is evaluated, this one you have to be very, very clear about how the evaluation happens in any if condition. In fact, not only in if, even if you write a loop and all anything, whatever the condition you put there, if knows what, after if what is there, after if there is an expression, if knows only true or false, if doesn't know anything other than true or false, if is already only if or if else if, they are only based on a value either true or false. It doesn't know what you really write here or here. The whole expression is evaluated and then it should return either true or false. That means if I put like this, this is not an arithmetic operation, this is a logical operation. Comparison operators and logical operations you are performing, because the operation, this expression should give true or false, this expression cannot give a value. So arithmetic operations are not to give true or false, arithmetic operations to perform arithmetic calculations. Let us say that this, let's talk about this age, age greater than or equal to 18, it is false. And then here and gender is F, which is called false, or gender is F, which is called true. How it is evaluated? So false and false or true is true. You know that OR operator, false or true is true. So false and true is always false. So since the final result is false, it will not go into the block, rather it skips to here. Again it comes here. Age is greater than or equal to 21, which is called false. And false because it's not male, or false. So false and false, which is called false. Then it would be skipped to this part. Gender is F, false, or I think what is it? True. So true. Then it goes inside and prints. It will not go to the next part. Okay, let's say I give not F, I give something else, then it is evaluated. So if and else, wherever you write else if or if else or whatever you give, you should always focus on the final result of the expression. That's very, very important. You have to, ultimately you have to calculate like this and check. You should know what is the value of and, what is the value of or, because if knows only true or false, if doesn't know all the, it knows means the language knows, but if doesn't care what you write here, if cares what is the expression that 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 this particular expression yields, true or false. If true, go inside the block. If false, go to the next block. Next expression or next condition is available. If it is if else if is there, again evaluate it. Otherwise, go to else. This is what how the whole if else condition, even the conditions in the loops and all, because loops are iterated until it is true. Any loop you take in the world, programming, the loop is iterated until it is true. Until it is true means that true where it comes from. The true comes from an expression. You can write a very big expression. Okay, you can write 100 lines of expression. It doesn't care. It only cares that what is the final result of the expression, true or false. You can write very big condition. Even I wrote actually for some program in Oracle. I wrote Oracle statements, Oracle procedures. The 3,000 lines of logic only for a condition I wrote. The metallurgy logics are like that. Long, long back. Even I cannot write single procedure in Oracle right now. So the 3,000 lines is just or condition and conditions and some comparison operators. But ultimately, whatever you write, what if else no, true or false. If true, go into the if. False, go to the next condition. Again check, again go. That's what it does. More than that, it doesn't know anything. Loop also same thing. That's what about these if else condition and then else if condition. Okay. Next session, I'll give you a task on this. Uh, if else condition and else if condition. I'll give a task on this. That's what actually for today's session. I hope you understand this. I'll push the code to GitHub location. Okay. I think we can meet Monday and then tomorrow probably